In students, we discussed about the series combination of cells. Now we'll discuss about the parallel combination of cells. In parallel combination of cells, if the cells are like this, because the derivation part I'm not going to solve here, I'll just do it in my JEE videos. But here, if okay, I have taken two cells in series. So in series we discussed that if this is E1 and this is E2, this is E1 plus. This is fine. Now in case of parallel combination like this is parallel combination, means this combination, if it's connected to any external resistance, if this combination is connected to any external resistance here, then both of them will contribute to the current. You can also apply the principle of superposition that also we'll discuss in great detail in JEE video lectures. But for the time being, if you think that only one cell is not there, if this cell is not there, then this cell will only allow the current to flow. This will make the current flow in clockwise sense. If this cell is not present, only this cell is present, then this will also make the current flow in clockwise direction. But the current in this case and in that case will not be same if the EMFs are not same, but they would have their individual current. Suppose the current that it will send, if this is not present, is I1, and this will send its own current if this is not present, is I2, then obviously the current in this branch will be the sum of the current I1 plus I2. So this parallel combination of cells we are interested in the effective, this is the net EMF of this combination. This combination is replaced by a single cell of EMF E1 plus E2. Similarly, if I want to replace this combination of these two cells by a single cell, what is the equivalent of these two cells? Okay, if its internal resistance is R1, internal resistance R2, what is the equivalent? That we are going to see. Okay, now E1, R1, E2, R2. So the net EMF is the sum of EI by RI divided by sum of RI. This is the formula that we are going to use for net EMF. And net resistance, internal resistance, will be, or I'll write this way, 1 by RI sum of resistance. Okay, this is how you find the net internal resistance. This part I will just explain to you. I think this is not clear to you. This I'll explain, and we will take one example also. What is the meaning of this? Let me explain to you. If I have a cell of EMF E1 and internal resistance R1, suppose there are three cells of EMFs E1, E2, E3 and internal resistance R1, R2, R3. Their positive terminals are connected together and the negative terminals are also connected together. This combination will be equivalent to a single cell and internal resistance R single cell of EMF E net and R net. Okay, now that means how to reduce this combination of three cells into a single cell and one internal resistance. So this is what we discussed, that the formula is E net is sum of 1 upon E1 upon R1 plus E2 upon R2 plus this and so on. So EMF E net you can write as net EMF is E1 upon R1 plus E2 upon R2 plus R3. Divided by 1 by okay. So this is the formula. And what about the R net? 1 by R1, R3 and so on. If any one of the cell is wrongly connected, here all the positive terminals are connected here to this point. Here all the negative terminals are also connected to this point. So this is negative, this is positive, this is negative, and this is positive. This is what is the outcome. The combination of this has equivalent value. This, if you have one cell whose EMF is this, and internal resistance find from here, then you can replace the whole combination by a single EMF and resistance. Let us take one example. If the one of the cells is wrongly connected, suppose plus minus and plus minus here. So one of them is wrongly connected, means suppose this is minus and this side is plus. The battery is reversed. If you connect this negative terminal with this and positive terminal with this, then the term that is E2 upon R2, E2 upon R2, this term will be negative. If you connect it reversely, this will become negative. Okay, this part will be negative. And there is no change in the internal resistance, whether you connect this way or that way. The resistance are always added, but these three resistance are in parallel, and you know the parallel formula. The parallel, in case of parallel combination of resistors, their reciprocals are added, and that is equal to 1 upon R equivalent. This is the equivalent. I will just take one example to help you understand. Suppose that I have a cell like this, 2 volt, 1 ohm, 3 volt, 2 ohm, 4 volt, and 3 ohm. These three cells given are this is the EMF, this is the internal resistance, EMF, internal resistance, EMF, internal resistance. So if all these are replaced by a single cell and one internal resistance, what is that value? That you write here. Okay, that is the meaning of this. So then we know that the EMF equivalent EMF is this divided by this, E1 by R1, that is 2, plus 3 by 2 plus 4 by 3 divided by 1 upon 2, 1 plus 1 upon 1, 1 upon 2, 1 upon 3. This comes out to be, if you take 6 LCM, then this is 6 to the 12 plus 2 3 the 6, that is 9 plus 8 divided by 6 divided by, here also 6 in the LCM, 6 plus 3 plus 2, 6 plus 3 plus 2. This comes out to be 6 cancels. This is 29 divided 11. This is the net EMF. So that comes out to be nearly 3 or little less than 3 to whatever it is. So that means if I will replace this combination by a single EMF, whose EMF value is this 29 divided 18, 11 volt, and the internal resistance is 1 upon 1 upon 1, 1 upon 2 plus 1 upon 3. that comes out to be 11 by 6. 11 by 6, the 6 goes up. So this is what is internal resistance. It is, if it is 10, it is 0.6. If it is more than a little more than 10, so to little less than 6. Suppose it is 0.59, nearly 0.59. So this ohm and this much voltage is nearly, if it is 10, then it's 2.9, and nearly it is 2.98 volt, something like that. So if I have a battery whose CMF is 2.98 volt and internal resistance is 0.59, that single cell will act equivalent exactly the same way as this combination will act. So that is how you. And if this is wrongly connected, if this is connected, this negative end of this battery is connected to this side, and positive terminal connected to this side, that means you just change the battery. Then this will be negative. This will be negative. Okay. Then whatever is the answer. Okay. So thank you very much.